We're doing a package problem in this video. The problem says package with square ends has a combined length and girth of 120 inches. The surface area of the entire package is 3,600 square inches. Determine the dimensions of the package. Okay, so first thing, there's an equation for the combined length and girth, and that is 4s plus L is equal to 120 inches. Okay, so that's the length and the girth combined. Now that's an equation that was given to us. Now we need to use our knowledge of surface area to come up with another equation, because you'll see, like we usually have in algebra, we have two variables we need to solve for, but we only have one equation here. So let's use our surface area knowledge. Now, before we get to that, here's what our package looks like, a crude representation. Okay. So it's got two square ends. We'll call these dimensions S and S. It's got a length of L. Okay. So if we want to do the surface area is basically the combined areas of all sides. So to do like this side, that area is just length times width. Okay, so it's just S times S. Now keep in mind we've got two of those ends, one right here and one on the other end. Okay, so if we're going to be doing S times S for the area of one side, we've got to times that by 2 for the area of both sides. Okay, now that's just going to become 2S squared, but we'll get there in a second. Okay, so this is just for the two ends of the boxes. Now, if we were to do these four areas right here, so this area, and the area behind and on the bottom, well, we've got a dimension of L for the length, and this side length, once again, is just S right here. So to get the area of one of those faces, it's just going to be simply S times L. Okay, but since we've got four of those faces, we're going to times that by 4. So when you add up all the faces, you're going to get your 3,600 square inches. Okay, so that is our equation for surface area. This is our equation for length and girth. Okay, so let's clean this up a little bit and just take a tally of everything we have so far. So they told us that 4s plus L is equal to 120. We just figured out that 2 times S squared plus 4 times SL should get us our 3,600. We've got our two equations, we've got two variables to solve for. Let's go ahead and do it. This L looks pretty easy to solve for. We're just going to need to minus this 4s over to the other side. So just imagine us subtracting 4s from both sides of that first equation, leaving us with L is equal to 120 minus 4s. We're going to take this expression for L, plug it in every place where we see L up above in our second equation, which is right there. Okay, so what that's going to turn into is, we're going to get our 2s squared plus 4 times S times 120 minus 4s, and that's equal to 3,600. Okay, so now we can distribute and simplify. We'll do that in a couple steps. 2s squared, let's distribute that 4s through. So 4s times 120 is 480s. 4s times 4s is 16s squared. Our 3,600 is still on the other side of the equal sign. And continuing to simplify, we're going to combine our like terms. We have two terms with s squared, so let's combine those together. Negative 16 plus 2 is negative 14 s squared. We've got our 480s still right there. And let's say we move this 3,600 over to the other side, just because we want this in standard form. So we're probably going to want to use the quadratic formula. So we've got minus 3,600 as our constant, and that's all equal to 0. Once again, our coefficients are A, B, and C here. and let's get to the quadratic formula once again. So x equals, or in this case, s is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and substitute our coefficients in for those letters. So s is equal to negative 480 plus or minus the square root of 480 squared minus 4 times negative 14 times negative 3600. I'm losing room here. Let's see if I can make that up. 3600. That's a 6, by the way, right there. That's a 6. And that's all over 2 times negative 14. Let's go ahead and simplify that as best as we can. So I'm going to get my calculator out. Okay. So nothing's really going to change at the beginning of this equation. We're still going to have our negative 480. But now we've got our plus or minus. And then let's do some stuff to the bottom of this root. 480 squared is going to be 230,400. And then you'll notice we've got 1, 2, 3 negatives here, which means 3 negatives make a negative. And then we're going to take 4 times 14 times 3,600. And that's going to get us 201,600. Okay. And then down below we've got 2 times negative 14, which is negative 28. That's looking pretty good as far as simplifying goes, but there's one more thing we can do under that radical. We can combine those terms. So x equals negative 480 plus or minus the square root of, well, what's 230,400 minus 201,600? Well, that just happens to be 28,800. We're putting that all over negative 28. Now, in this example, they gave you, I think they probably gave you one of the solutions, because remember, quadratic formula always yields 2 solutions, because you've got a plus and a negative, so plus or minus the square root. You see that right there, this right here? You got 2 routes. So any solutions that they already gave you represent just one of those routes. So when you do this quadratic formula, make sure you do both the plus the root and the minus the root. And whichever one is different from the example they gave you, that's going to be the dimensions that you're looking for. And then don't forget at the very end, this is just solving for s. You need to take what you get for s and plug it back into your original equation up, system of equations up here above, way up here. You can plug it into really either of these 2 equations to solve for what L is. I'd recommend doing this one right here, since you already know it's pretty easy to solve for L. But once you get S and L, you are done. Okay, and make sure you follow the directions for how many decimal places you need to round it to. But that is, in a nutshell, how you do that problem. Good luck with doing the rest of the quadratic formula calculation. Hope this helps.